Hi, Assalamualaikum and very good day everyone. So now we learn on the new chapter, which is spectroscopic methods. So this chapter we divided into 3 parts. So part 1, part 2 and part 3. So the course outcome for this particular chapter is CO4, while the program outcomes are PO1 and PO4. So the topics involved in this chapter can be divided into 3 major topics. So the first one, overview of spectroscopy, followed by Beer's law, and finally equipment involved such as UV-vis, infrared, atomic absorption spectroscopy, flame atomic emission spectroscopy. So at the end of this chapter, you must be able to describe principle of absorption and emission in spectroscopic method, explain and differentiate the theory and instrumentation process of UVs, FTIR, AAS, FAES, and finally determine and explain quantitative and qualitative applications of UVs, FTIR, AAS. Okay, first and foremost, what is spectroscopy? Spectroscopy is the interaction of matter and radiation at different light frequency. So the electromagnetic radiation is a form of energy with properties that can describe in terms of waves or particulate photons. So these are the example of the spectroscopy, so which covered at certain frequencies. Okay. So why is spectroscopy useful in analytical chemistry? So spectroscopy is a technique used for detection of substance when it interacts with the radiation. So these are the example of 2 equipments under spectroscopy. So UV-vis and infrared. Okay, light is a form of electromagnetic radiation. So the electromagnetic radiation can be formed in 2 views of light. So first, in terms of the wave model, okay, so there are the wavelength, amplitude, frequency, wave number, okay, velocity. So the speed of the light in a vacuum is 3 times 10 power of 8 meter per second. And it can be in the form of particle model. Okay, so the particle model is in the form of energy. So energy required of photon to give this transition. So the energy is aside from the lower state to the higher state. So energy of wave can display as E equal to hv, where the h is the Planck's constant. Okay, so these are the how the electromagnetic spectrum related to the spectroscopy. Okay, they have the wavelength, they have the frequency. So here we will learn from the infrared until the here. Okay, so common spectroscopic methods based on electromagnetic radiation. So the gamma ray, X-ray, vacuum UV, UV-vis, IR, microwave, NMR. and so on. Okay, so generally when we talk about the spectrum, they will explain as the wavelength, and the wavelength got their own color. Okay, so for instance, for the visible color, so the visible wavelength between 380 up to 780. Okay, so the interaction of matter with electromagnetic radiation can be in three types: either absorption, emission, or scattering. So what are the differences of these three types? So the absorption is transition or excitation from a lower energy state to a higher energy state. So from the lower level to the higher level, from radiation field to an absorber. While for the emission, a transition or relaxation from a higher energy state to a lower energy state. And the scattering, a redirection of light due to the interaction with matter. So it might or might not occur with transfer of energy, or it might or might not have different wavelength from the incident light. So in a simple diagram, so absorption is the transition of the energy from the lower state to the higher state, while the emission is the relaxation from the higher state to the lower state. Okay, so these are the example of spectroscopic which use the emission, absorption, and radiation. So emission, radiation is the emission spectroscopy, fluorescence, UV-Vis. Okay, while the absorption, spectroscopic or photometry, X-ray, UV, visible IR, NMR, ESR, and the scatter is a Raman spectroscopy. Even though we know the terms of scattering, but in this chapter we focus more on emission and absorption, radiation. So how does the matter absorb radiation? So the matter can absorb the radiation in the different ways, either rotational transition, or vibrational transition, or electronic transition. So the possible type of transition, for example, for UV, most of the time they use electronic transition. NIR, they use vibrational transition. Visible, they use outer electron. For infrared, they use rotational or vibrational, and microwave use rotational transition. Okay, so another terms that you must understand is the absorbance. So absorbance is attenuation of photons as they pass through a sample. And this spectrum, the graph that produced from the result, we call as a spectrum. So absorbance spectrum, a graph of sample absorbance of electromagnetic radiation versus the wavelength. Okay, done. So see you on the next part. Bye.